Hello everyone, I'm back with another interesting video in CCNA, that is DHCP and DNS. We're going through within this slide with these two chapters, DHCP, that is a dynamic host configuration protocol, and DNS, that is domain name system or domain name service. So let's start with the DHCP. As you know, the DHCP is dynamic host configuration protocol. The basic task of DHCP server is to providing IP addresses to its client automatically without user intervention. So user need not to mention or user need not to specify any IP address to each and every client in network. These tasks will be performed by DHCP server, and DHCP server, as providing the IP addresses to their client, it will also provide as well as subnet, default gateway, domain name, and DNS server name. So the DHCP plays a major role in our network structure, and we can say DHCP is used to provide the IP address automatically to the client without user intervention. So let's start the what is DHCP and what is DHCP process. As we know, DHCP is dynamic host configuration protocol. It used to provide the IP addresses to their client, and basically DHCP work on DORA process. That's a DORA. It's a discovery, offer, request, and acknowledgement. Suppose let's have an example. If we have thousands of clients in our network and there's one DHCP server, so how each and every client get the IP address from the DHCP? Or the client is live in our network that can get the IP addresses from the DHCP, but a new PCs that newly installed or those PC who is not working for some hardware reasons, when they start up or when they boot up, so how can they get the IP address from DHCP? Because DHCP will never know which PC is not working or which PC has been changed or replaced. It just gives the IP address and register the IP address in its database. So we can say DHCP is work on DORA process. It's a discovery and offer and request, and we can say acknowledgement. As discovery described with the look for the clients, offer means the offer the IP address to client, request, then client request for the IP address from the DHCP, and DHCP gives the acknowledgement to client. Now, as we know, this is a DORA process. So let me give you a brief how DHCP work in our network. So in this example, we have a server and we have a few network machines or client. And as we know, all clients have the IP addresses except the one. There's a newly laptop is configured in our network. Except newly this laptop, all they have the IP addresses like 5, 6, 11, 118 and 145. So how DHCP perform the task of DORA process? So it just gives the check for the discovery IP addresses, and if you not found the IP address, it check the client and maintain his record, and he's offering the IP address to that client. I'm giving the IP address, and after that client requests from the DHCP, please give me the IP address, I need the IP address. Then DHCP gives the acknowledgement to that client, you got the IP address and you have a new IP address in your network. Or we can say DHCP work on DORA, that's a discovery, offer, request and acknowledgement. So this is the whole scenario how DHCP work in our network. Or next we have a DNS. As we know, the DNS stands for domain name system or domain name service. The basic task of DNS is used to providing the mapping of IP address to host name or host name to IP address. As we know, to us it's very hard to remember the each and every IP addresses like phone numbers, or like we have examples of our smartphone, mobile phones. We have the contact list. In contact list we have the name of our friends, colleagues and the person who know, but we'll never know exact the number. We never remember what his number and what the number we are using for it. We just go through with the name of our person like A, B, C, D, and we have a specific name, and after that we just dial that name, and at the back end it just check the name with, it has only the phone numbers, so it translate that phone number to phone host name to your phone number, or we can say it just translate your contact list to your phone number. In the same way, in network, the DNS plays the same role. It just convert your IP address to host name and host to IP address. Let's understand a brief on it. Suppose we have a client and we have a server. A client wants to communicate with the server. For example, we're looking for the www.google.com. First, the client send the request through our DNS local cache in our computer. If the cache is in our computer, it just gives the reply to client, here's your www.example.com. If it's not found in the cache data, then it will ask for your root web server, that I need a www.example.com. Then root server check the database in his data, and if you found that example.com or that specific website, it will forward it to that example.com server, and this request goes to our requested server, and the data is found with that server. Then server reply to our root web server that here's your data or here's the request, you can get the query. Then root server send it back to our DNS server or local cache, and this local cache reflect to us and gives us our reply that here is your result, you can go with and you can have to open your browser. So this is the whole process how DNS work. Basically, DNS used to mapping of IP to host name or host name to IP. So this is the whole scenario of how DNS work. Next, we can say in very simple manner or simple way, IP address to host or host to IP address. I can see in picture the 192.168.1.80 translate to myexample.com, or it can be myexample.com to IP address. So this is the whole scenario of DNS. Next, we have a DNS server. As we know, DNS server, it has the database of all the servers in the DNS, like the domain name services, and it's a DNS servers which manage the DNS services, and the name server manage the internet domain names. So the responsibility of DNS server plays a big role in internet or in the field of World Wide Web. So basically there are two types of DNS server. There's a primary DNS or secondary DNS. The primary DNS is related to domain zone, and it's the main primary. It works as a master and responsible for communicating with the secondary DNS services. Or we have a secondary DNS server is referred as a slave, or it's a backup copy of our primary DNS. Later we have a DNS query. As we send the request gone through with the different form of the query. As we ask for the google.com, then how google.com will work with the DNS server and how it will translate this query and how it will understand this query. So we can say we have three different types of query with the DNS system. First is recursive, second is iterative query, and third one is non-recursive query. In recursive query, we can say the DNS resolve must provide the best answer. If you not find that website, it gives the error that I don't have the database, or I am not finding the what you are asking for. And iterative query, the DNS resolver result with the find with the best answer, but if it will not find the answer in its database, it will not give the error, it will just forward it this website to root server. Then root server will find another second domain name system, and it will go for the website looking for another website and go for so on until the record is not found. And non-recursive query, as we can say, the name describes, a non-recursive query is already know the answer. It's neither its work is immediately returned to DNS as record is stored in the local cache. If the local cache is stored with that name, it will give you the answer promptly. So this is a DNS query type. Next, we can say we have different types of DNS record, or we have the DNS server has a multiple database to resolve the different types of query. So these queries said to be as DNS record. In DNS record, first we can say we have different types of record. We have A record, MX record, CNAME record, PTR, SRV, SOA, and MX record. So we can just go brief with it that what is A record. The A record is used to providing for you resolve the FQDN name or host name to IP address. In the reverse of it, that's a PTO record, that's a pointer record. It's a opposite of A address, and we have a canonical name. It's just a different name or the duplicate or alias name of the another host or website. Mail exchanger, that's SMTP email server. We have NS record, which provides the address of the different name of the server. We have the SRV records, which contain the different types of services like MX or communication. It's a communication protocol, or SOA, that's a start of authority. Basically, it's used for replicating purpose. Each zone file must have an SOA records. So next we have a Telnet and SSH. What is Telnet and what is SSH? So Telnet is a networking protocol. It's simply used to communicate over the network remotely from one PC to another PC. Or we can say the Telnet work on the port is a 23 by default. And suppose we have an example here how Telnet and what is the briefing of Telnet. Suppose a computer A communicates with the computer B. A computer 1 is another city and 2 is another. Then we can say the computer A getting the access from computer B by remotely, and this protocol will perform by Telnet. So this is the scenario of the Telnet, to getting the remotely access of another PC from anywhere in your LAN or from anywhere in the world. So this is the Telnet. Next we have a SSH. The SSH is the advanced version of Telnet. It's said to be a secure shell. In the same way as the remotely communication with the different server, but using the SSH protocol. The TCP port using by the SSH is 22. Let's understand with the scenario with it. In the same way we are using the Telnet, but SSH, if the computer A want to communicate with computer B, so we have an secure manner. We have an security on it. We can say the SSH provide a secure communication, or SSH use a public key encryption. So your data cannot be easily accessed, attacker or easily accessed hacker from between the communication from A to B. Or so we can say this is the SSH is a secure socket shell. So this is all slides. Thank you for watching this video. I hope you like this video. See you next time for more interesting video in CCNA. Goodbye and have a nice day.